Hi everybody, I have a nice idea and I think it's pretty far up on the list of nice ideas I had in my life. It's a short list, but but this one is pretty far up. So I had this small epiphany that when you have a file, let's say this right here, this is a text file, and you want to encrypt it, what do? You set a password, and that password will transform that file into a new encrypted file that contains some bogus text that nobody can read. For example, this. So you have some clear text, and a password transforms that file into some encrypted file that nobody can read. Now, the issue is, anyone who sees that you have a file like this, especially if it's called something like secret.enc.encrypted, everybody's going to know that this is an encrypted file and you have some secret. What if you want, or what if your goal is that nobody should ever know that you have a secret? In that case, it would be super nice if you, instead of just transforming a text file into an encrypted file, if you have a text file, let's say this one, txt, text file, and then you provide some key file, let's say this one, or some transformer file, let's say this is the transformer, and then you get a different text file, let's say txt, with your hidden, with your secret. Okay? So from one clear text file, using a transformer file, this thing right here, if you apply that transformer file to the clear text file, you get a new clear text file with your secret. So you can keep your clear text file on the disk, store away the transformer file somewhere, USB stick, whatever, KeyPass, some password manager, wherever. And then you can apply it to that file and get a new clear text file with the embedded secret. So, okay, long speech, but the point is we want to hide data in clear text. How's that possible? Well, technically, that transformer file can just be the difference between the text file and the text with the secret. So we're going to code some C today. So let's create a new directory. Let's go into projects and let's create a directory. Hide in clear text. Hide in clear text. And hide in clear text will contain a file, hide in cleartext.c, and let's include something, include standard IO, because we're going to have to read two files, and those two files will be provided as arguments, I would say. We could also do two standard inputs, or well, two input streams, but let's do two files. So argc and constant character pointer argv, which is the values array. Oops. And good God. What do? First, we check if the argument count is not equal to 3, which is the same as two arguments provided, two positional arguments, and the program name itself. So if that argument count is not 3, then we print a usage instruction. Usage is the program name. and then file1 and, well, or clear text file and secret text file. All right. New line. And let's provide the argv0 as the program name. And then we should be good to go as far as the printf goes. And then we can exit the application with an error code because it hasn't succeeded. That error code is available in standard lib. And that exit function is available in standard lib. All right. I think that's fine for now. Let's test whether it works in this terminal. So let's go into the projects directory and compile this using all warnings. Let's also do extra. Let's also enable debug flags, hic.c, and output file is hic hide in clear text, and input file is hide in clear text.c. All right, it's compiled, and let's execute. And as you can see, it prints a usage instruction here, and the first, that's nice. The first, well, element of the usage output is the program name, which we provided here via argv0. All right, so that seems to work. Let's try to execute it from outside. And as you can see now, the usage has changed its output. So that's very useful. All right, if we provide two arguments, let's say first and second, then we should get no output because we haven't coded anything yet. Now we have to open the two files and then somehow generate the transformer file. The transformer file is the magic. We have to generate the transformer file from the two files. How can we do that? We have to fopen the first file, I would say. And the first file is argv1. Let's create a constant character pointer first. Or file, let's call it file1. And that's coming from argv1. And let's open file 1 here. And somewhere at the end, we can also fclose file 1, although that's not strictly necessary because we're working with two files only. And on exit, every C application will automatically close file descriptors. Okay, and we open file 1 with read-only access. We don't need anything else. We don't need to write. And this returns a file descriptor, I think. File descriptor. We should name that one probably file 1, and the character pointer should be file name 1. File name 1. And maybe even, no, we can even shorten that to fn, which I've seen online quite a lot of times, but let's write things out. File name 1. Okay. And I'm a bit confused by the warning that I get here. Let's open the compiler pane and try to compile. And as you can see, there's a warning. And why is there a warning? It has to do probably with incorrect usage of the fopen function. So let's check the man page for fopen. And as you can see, fopen is to be called with the path name and with a mode. And the mode is also a constant character pointer, so it's a string, and I called it with a character. So we have to replace the single quotes with double quotes, and then that should be fixed. And it is fixed. And now we can technically also open the file name 2, which is the next argument. Let me just increment all the numbers here, and then we can also close the second file. So now both files should be opened, and we can probably read from those files using fgetC. And fgetC returns integers, which are actually characters, from a file stream. And how do we do that? I would say we should write a function, and that do we need a function? I don't know. How about writing a big monolith here? No, it's just a small piece of program, so I'm not sure if it deserves a function. We are opening files here. Let's try to implement it here. If the code blows up too much, then I will create a function. And we loop over the... Now, we have to code a loop that loops over the files. So while fgetC of a stream, well, fgetC, let's say file 1 is not the end of file. That sets the values of the characters for file 1. C1 is characters for file 1 or coming from file 1. And then we do, so this is reading from file 1, but we should also read from file 2. Should we do it in the same while loop? I'm not sure about this. Technically, we should read from the longer file, I would say. Let's try to read from file 1 for now, just as an intermediate test. And as a test, we can even put... we can write back to standard out using fputC, or just putC. Yeah, putC writes to standard out by default, and fputC writes to a file descriptor. So here we write to standard out, too few arguments. Wait, putC, man putC. Also needs a stream specified. So we could do standard out just to make it explicit, but we could also use the put character function. It doesn't make a difference. So let's see what happens now. Now I would expect the files to be opened and file 1 read character by character and printed out to standard out. Let's see if that works. Oops, what did I do? Let's compile and let's execute. And before we execute, we of course have to create a clear text file and a secret file. So let's say, hello, this is my letter to Mr. Rockefeller. I am honored to announce that share prices rose by 13%. Best regards, Daniel Hirsch. Just some meaningless clear text, all right? And maybe to simplify our coding a bit, but also this will limit the program a bit, but it doesn't make a difference for this video. I think it's good enough if we just copy the clear text, create a secret file, and let's just assume that both files have the same length. And now we can write some secret in here. Let's say secret. And let's say my secret is I actually lost all my money. Please help. Oh, and I have to be careful not to change the length of the file. So let's say this is the embedded secret. So when the file is decrypted or transformed, then I want to have this secret here show up in the resulting file. So now we have a clear text and a secret, and both have exactly the same length of 131 bytes, which makes our coding quite a bit easier. And let's execute hic, the hide in clear text program that we're coding, with the clear text and the secret, and it's printing out the clear text to standard out as assumed. Now, what do we do now? Now, we are extracting all the characters from file 1, but we should also extract all the characters from file 2. We don't have to do any length checks now because we're making our lives easy, just assuming that both files are exactly the same length. So let's also read character 2 from file 2. Character 2 is equal to fget c from file 2. And when the loop terminates, because C1 is end of file, then file 2 will also be read completely because it has the same length. So I'm cheating a bit, but for the sake of this video, it's a perfect demonstration. So character 2 is being retrieved from file 2, and now we have to generate the transformer file. So instead of putting to standard out C1, we can put to standard out C1 XORed with C2. XOR, if we apply XOR, if we apply C2 as XOR to C1, then it will result in some byte result. And when we XOR again, then we can retrieve the original secret, I think. So what I'm thinking is that we are generating a difference file based on XORs. We could also do simple arithmetic, I think. We could do plus and minus even. We could do a difference between characters probably. Maybe this is even simpler. But XOR is maybe harder to read. I don't know. Okay, let's try with a difference because that's just that's even easier to visualize. So yeah, let's see. Let's see. So we calculate the difference between, let's say, C2 and C1, and we write that to standard out. Now that's only going to generate bogus because those are not going to be in the range of valid ASCII characters or UTF-8 characters. And then we can redirect standard out to some resulting file that we can name ourselves. And then when we want to regenerate the secret text based on the original clear text, then we can just apply the secret at the transformer file and just reverse that using a simple addition. So let's call the encrypted character CX. We should do that here. CX is equal to, or cdiff. No, let's call it CX. That's nicer. Is equal to C2 minus C1. And then we put to the console CX. And of course, CX is an integer. Cx is the magic character that's going to do all the magic here. So Cx is equal to C2 minus C1. That means when we want to, well, let me create a new file here. Cx is equal to C2 minus C1. So this is the original file, and this is the secret file. So if we have the original C1 and Cx, then we can generate the secret file just like this. C2 is equal to Cx minus C1. And that should then reverse all the logic and give us our secret. Let's see. I find this, by the way, this is just super simple, and I love these simple concepts. I hope it works the way I think it works. But I just love when you have a nice simple idea. And yes, I know it's not cryptographically secure, but it's just fun to play around with. So hide in clear text. Let's execute the program. We have a clear text file and a secret file. Let's check. The clear text is this. The secret file is this. So both have the same length. The secret just has this embedded in the file. Let's call that function. And as you see, nothing happens because I haven't compiled yet. And now let's execute again. And there's just some bogus stuff printed to the console. The reason is that the difference between those two files results in a ton of zeros because they are identical in most places. But in the places where they are not identical, there's a short section of secret data, and that's resulting in this difference here. So we have 0, 0, 0, 0, zeros, and then some bogus stuff, and then another sequence of zeros, which is not displayed and visualized in the standard out in the terminal. All right. So that is, I think that should be it. So we can even save that transformer. Or should we call it diff? Let's call it transformer. We can save that transformer in a transformer file. Now we have a new transformer file here, less transformer. We can see it anyways, and that's how it looks like. So this is the long section of zeros. And then the secret stuff followed by more zeros. And we can even do a hex dump of the transformer. And as you can see, this is even more visual. So it's a couple of zeros here, some difference values here, and more zeros because the starting strings and the end strings are identical. Okay, now we have generated the difference file. Now what I want to do is I want to reverse that. What if can I reuse the existing program to reverse that already? So this is C2 minus C1. If we input the files in a different order, then maybe we can already reverse it using that what we already have without changing or without implementing further logic. Let's try. So let me just create a new terminal. Oh, not that one. Let me just create a new terminal down here, just so we have a nice little overview of what's going on. And then let me clear this one and move it here. So we have the clear text, the secret, and the transformer. Now imagine we have only the clear text file on the machine. What happens if we do clear text, if we do hide in clear text, and then we apply the transformer to it, does that work? I don't know, because it's a difference, and I don't know if we have to explicitly reverse it using a plus here. I don't know. Let's just try and see what it prints out to standard out. Yeah, that doesn't work. What if we get the transformer first and apply the clear text? Maybe that will reverse that. That doesn't work. So you can see that something is happening here, but it's not really what we want. And that's probably the reason why, in order to save us some programming effort, we can use some easily reversible operation. An operation that reverses itself if you apply it twice. There's a word for that. I just forgot it. If you use the difference here using the minus, then you have to reverse it using a plus. But if you use XOR, you can reverse it by XORing it again. So maybe that's already working. Maybe the XOR is the better choice. So we can compile that, and now based on the clear text, we have to generate, based on the clear text and the secret, we have to generate a new transformer. So let's do that. We can also have a look at the hex dump of the transformer. As you can see, it now has I think this is a different hex dump, or should be. And now if we apply the transformer to the clear text, to the secret, we have the secret file. We have the clear text file and the transformer on the machine. Yeah, we have the clear text and the transformer, and let's see what the result is. And there it is. This is it. So it works. So based on the clear text file and the transformer, you can generate the text that embeds the secret inside itself. Yeah, just for recalling, the clear text is this. This is some message. This is just some clear text file. And the transformer is this. This is some bogus stuff. But if you combine both, then you can retrieve a secret embedded inside the clear text file. Now, what you have to do is, in practice, you can store away your clear text files, which can contain arbitrary code and arbitrary text anywhere. You can write anything in them. Hello, I like flowers. Hello, my name is Daniel, and I've been to Italy. God knows what. And then you can modify those files, save them elsewhere in secret files. Then you generate the transformer like this. This generates a file that is a binary file. And then you open your file explorer, for example. Take that transformer file here. This is the transformer file. You save it somewhere on a USB stick or somewhere, and you just delete the secret. So now the secret is not on your file system anymore. And what you can do now is you can call the program with the clear text and the transformer. Now there is no secret on the file system anymore right now. And you can of course save the program somewhere where it's hidden as well. And just like so, you can hide inside clear text. This is the clear text. I'm honored to announce that share prices rose by 13%. Just like this, you can hide in this clear text file using the transformer file a secret message. I love this concept. I hope you enjoyed it as well. If you did, then stick around and see you next time. Bye.